This is a talk about Azure Storage and digital transformation in key industries. So basically, what I'm going to spend this time is really not so much talking about storage and features, but giving you a very brief overview of Azure Storage, Azure Blob Storage, but then let our customers and our partners really tell you their story of how they are using Azure and Azure Blob Storage to make a difference in their industries. We're going to, in terms of structure, narrow down our focus to healthcare, financial services, insurance, architecture, engineering, and construction, and media. But the problems that they're going to talk about are broadly applicable to other industries. So I hope you'll leave this talk really with a sense of understanding how you could take storage, which is so key to all of the work that we do, and apply some of these learnings, apply some of these solutions in your industries. And this talk really is not about the features. We have a different talk for that was yesterday that goes through all of the new announcements we have in our object storage platform. I'll highlight a couple of features, on one feature on each vertical industry that really we learned from that industry and built the feature for them, but it's applicable beyond that, of course. So it is really more about the end-to-end solutions, and kind of a good mix of here's the problem, here's the solution, but also here's the architecture. So our speakers, our guest speakers have worked really hard to kind of abstract the learning from what they've done to give you sort of an architectural sense of if you're solving a problem similar to this, here's some of the things to think about. We've had a huge number of sessions for the Azure Storage team. Most of these are now, of course, in the past. I think we may be the last session of this set. But I'll leave this slide up here for a second, just so that if there are other topics you were thinking about, all of these talks are, of course, going to be up, recorded, and the slides are going to be available. So if there was something else you were looking for, we've probably covered it in one of the talks. So let me jump in with a little bit about Azure Storage and what we do. And Azure Storage is basically a foundational building block of Azure, along with compute and networking. All of our Azure services are built on those three core blocks. We get hardware in our data centers, we go deploy the compute manager, the network manager, and the storage system, and then everything else above it is built on those three services. It's also a building block for all of our Microsoft service offerings. So even though you may not be using blob storage directly, if you are using Office 365 or OneDrive for Business, or if you're using Xbox or Skype, you are using our object storage platform underneath the covers because it is the durability layer for all of Microsoft. So this leads to some interesting things. When we talk about storage, we talk about in these terms: hyperscale, durable, available, secure, open, and hybrid. I'll dive into a couple of these. Hyperscale, because we run all of Microsoft's data workloads as well as all of our external customers' data workloads, it's a really staggering amount of data that we pull in and push out. We do over 30 million transactions a second across trillions of objects. In basically the next hour, we'll do, as of data from last week, we'll do about 7 petabytes of ingress and egress in a single hour, and over 100 billion transactions over the data that we store. Add that up to a year, and it's a really phenomenal amount of data. It's about 60 exabytes that ingresses or egresses from our storage platform, and over a quadrillion transactions. That's 1,000 trillion transactions against that data. The other aspect of storage that I'd like to call out here, of course, a lot of the other things around durability, security, availability. We've covered that in other talks. But the other thing I'd like to highlight is the hybrid approach in two respects. One is our partner ecosystem. We know that storage is sort of a means to an end, right? You don't just go buy raw storage and do something with it. In most cases, you're solving a need. It might be sort of a canonical need like backup and DR or archiving, or you might be doing something with your business units and trying to use an end-to-end solution. So we've worked very hard to build a good partner ecosystem both around things like backup DR, hybrid and tiered storage, but also around various industries and how we connect your problem to the solutions using cloud technologies, including storage. The second aspect of this is Azure Stack. With the Azure Stack GA, we have 100% consistent, API-consistent implementation of Azure Storage APIs on the Azure Stack devices. So if you have particularly gnarly data residency, compliance, et cetera, requirements where you cannot run your data workload in the cloud or cannot leave it in the cloud, you can still have your application coded to the blob storage API, but have your data entirely resident. So you can have a mix, and many of our largest enterprise customers that are multinational companies do this, where they have used the public cloud where they can. They use sovereign clouds like the cloud in Germany where they need to for regulatory reasons. And then in other countries now they're able to use these stack devices and have the same application stack running. In terms of the services we offer when we talk about storage, we offer on the IaaS front disks and files. So if you run an Azure VM, you're using Azure Storage for both the boot disk as well as all the data disks you attach to those virtual machines. That's our single instance storage, of course. Comes both in hard disk and SSD flavors. And then we have Azure Files, which is our SMB shared storage as a service. On the PaaS side, we have blobs, tables, and queues. Blobs are the core service that we'll spend a lot of time talking about, and that's our object storage platform. All of these services are built on a single unified distributed storage system, which has some great benefits in terms of having things like security, durability, consistency, applicable to all of the services. And you're able to get those benefits, and we're able to also pass along the economies of scale and cost that we get by having all of the data stored in one common layer. We talked about Azure Storage being a core service, which of course means it's available in all the regions that Azure operates in. So we have 36 GA regions today, 6 announced and coming soon. So that's really kind of the other thing. When you're thinking about data as a core part of your business, you can rely on those services that we're talking about here anywhere Azure does business. So this notion of data being critical to a business is not something that's new, right? It's been kind of known, certainly by us in the industry, for a long time. But it's interesting to see how it's entering popular culture. I always like to say that you've hit the business meme card when you end up in The Economist and they start talking about things like data is the new oil. This is an article from May, which is, they had a bunch of articles in that issue devoted to basically talking about how data is so core, especially unstructured data, is so core to the future of most businesses. And that's been reflected over the years in other things, ranging from tech sites like Wired to Forbes and Fortune. So it's certainly an interesting thing that people are realizing this. People are figuring out, rather than keep all my data on these disconnected silos or tape archives, et cetera, what can I do with that data? How can I add value with that data to the functioning of our business? At the heart of this data evolution is object storage. And Azure Storage's object storage service is called blob storage. It's used to store and serve unstructured data. And the reason object storage has become core to this data evolution is it is the highest scale cloud storage service available. It's also the most cost-efficient storage service available. So because of this sort of distributed hash table nature of how we store data in object storage without a file system, we can scale to exabytes or even zettabytes of data. And we really can do that at very, very high transaction rates, very, very high throughput rates, and scale out horizontally versus scaling up, which is what traditional storage systems used to do. We also then enable a very broad ecosystem of connectivity. So it's not just that these Azure services are built on top of Azure Storage for their data persistence needs, they also integrate. So you take something like an IoT in a streaming scenario, data comes in through an IoT hub or through an event hub, streaming data, IoT data, but then you usually end up putting it in blob storage for later post-mortem analysis. You take media, we'll talk a little bit more about that in this talk, and it's really tied up into how you store mezzanine files, how you do streaming, VOD streaming, live streaming. All of that is operating off of object storage as the origin store. So there really is that thing, even if you're not, again, thinking about other services in Azure, you're probably going to end up thinking about blob storage as one of your core pieces of your architecture. So as I mentioned, one of the things that we've been looking at is much more than the canonical cases of backup, DR, and hybrid storage, which are, of course, still very, very important. I mean, important enough that we have completely separate sessions on each of those. We've also spent a lot of time on these industry verticals. So some of the verticals we've covered, and I'm just going to quickly show these and get right into the customer stories. Our financial services, insurance, some partners and customers there, including compliance archiving, insurance, et cetera. Healthcare and life sciences, both medical imaging, genomics are sort of the vertical or the segments that are really popular for cloud lift. Media and entertainment, public safety and national security, that's become an increasing thing where you now have police officers around the country wearing body cams for 8 hours a day, and it generates a tremendous amount of data that needs to be automatically processed. There's no human being that can look at it and make sense of them. So that's something that's really become a cloud-first workload. And then other workloads, including automotive, a lot of the self-driving data, the self-driving stories that you're seeing are built on these enormous data models. These cars go driving around, they collect 20 to 50 terabytes of data per car for those cars you see on the road with all of those sensors, the video, the LiDAR, and everything. And then that has to be processed, analyzed, and computed to build the algorithms that are going to allow all of us to have these level 4 and level 5 driving, self-driving cars in the future. So with that, let me kind of focus on the 4 verticals that I said we were going to focus on this talk, starting with healthcare. So in healthcare, we're seeing cloud adoption in 2 verticals. One is medical imaging, and really the notion of these PACS and VNA systems, if you're familiar with them. All of us have had an experience of going in and getting an X-ray, maybe an MRI or a CAT scan or an ultrasound when we had our children, you got an ultrasound or your spouse got an ultrasound. And, all of this data has to end up somewhere. It has to be retained for regulatory reasons, has to be collaboratively, shared, et cetera. So that's definitely a cloud-centric scenario that's getting there. Genomics is another up-and-coming scenario where, we're rapidly heading to the world of personalized medicine where genome sequencing has gotten really inexpensive, and we have a great customer and partner who will talk about that scenario as well. What are the cloud benefits here that are really applying to this vertical? The first one, of course, is security and compliance. If you're going to store healthcare data in the cloud, has to be absolutely secure, absolutely protected from data leaks or disclosure, et cetera. So that's a big focus of that industry when they work with us. Again, highly scalable, low-cost storage, lots of data, so you do need both of these aspects. Optimized for HPC applications. A lot of this data is getting processed in HPC applications. It's not just an archive. It is getting processed. It is having ML models applied against it for insights. And then the global coverage, of course, because healthcare data is amongst the most regulated data residency, et cetera, matters a lot. So let me touch quickly on one of the features we've worked on in this industry and launched a preview at Ignite, which is storage scalability, and things. As we're talking about the big data space here, we went from 500 terabyte accounts to 5 petabyte accounts, and we're going to go much larger than that in the future. And we really spent a lot of time working on the throughput and transactions per second ability for these accounts for our customers to be able to use it. So with that, let me switch over to talk about where we are in terms of our customers using this. I'd like to invite Grant up here, who's the Chief Information Security Officer of Nucleus Health, and talk about the solution they've built on top of Azure.
Mic check. Hello? Okay. Just going to get one thing set up so we can do a quick demo, which will be super fun. Okay, so Nucleus Health, what we're all about is we are medical imaging. So we have been doing teleradiology and image sharing. So we've been doing teleradiology for about 20 years. We've been image sharing for the last 6. We've been in Azure pretty much the entire time, and Azure's been around. So we started with using blob storage. We've continued to use blob storage. And then through some of the different iterations, we've continued to stay abreast of new Azure technologies. So here are some of the customers that we've been working with, and the image sharing technology that we're using that is out there in the marketplace called RadConnect. So what are we doing to try to solve some of the problems that are happening, right? So what are we solving as problems? So we have frustrated patients. So when you go and you get your images taken, typically what's happened is you get this DICOM CD, and then you have to take it somewhere, and you've got to keep track of it, and it's very cumbersome, and then you've got to give it to the system that you want to go to, and they've got to import it, and it's very difficult to use. The systems that, or the health facilities that you go to, they don't like those disks either. They have a lot of problem with it. It's hard to move that data around. It's hard for them to work with the images, and then at the system level, once you get images into one place, you can't necessarily move them around really easily. And so you end up with this very congested, very difficult system to use. And this image is a good example of kind of like how hard it is of getting data around within health systems in this day and age. So what are we doing for a solution? So we are using Azure to try to help solve this problem. So we're bringing data into Azure to allow for really novel kind of use cases, right? So we are bringing the data directly into the browser. We are doing it with diagnostic performance with almost no latency as far as once the data is resident into the browser, you have diagnostic workstation performance. The great benefits of the cloud, obviously, we've got that infinite scalability. We can bring in as much data as we want to, and we don't have to worry about our enterprise storage running out of data. And then some of the other great benefits of Azure is, we've got this ability to have really enhanced security and have less downtime and investment at the level that people want to use it at, right? So you kind of can pay as you go. You can bring in some data, you can start working with it, and then as you get more comfortable, you can bring in as much data as you need to. And then as we've been designing this, we've been designing it for these advanced workflows. So we want to allow for machine learning and advanced artificial intelligence to be able to process this data so that we can improve patient care. So first thing I'd like to do is just show a little demo of the stuff that I was just talking about. And it's showing the wrong screen. Why? One second. Oh, do we have something? Maybe? Well, I'll skip the demo. I wish I could have shown it to you, but I don't want to take up all the time trying to do this. So we'll go back to the presentation. That is unfortunate. So anyway, the demo is going to show you that we can bring the images into the browser. We can show it very fast speed, client-side rendering. I'll talk to you about what we're doing in Azure to kind of give you a sense of it. So in Azure, what we're doing is we're mostly deployed as IaaS, and we're using blob storage to back in. So we're able to get the data out of blob storage extremely quickly. So there up in the upper right-hand corner, you can see a lot of different connected devices talking over HTTPS. We're talking on the health systems side. We're ingesting data, talking to the information systems at the local enterprise. And we're able to bring all that data in to the Nucleus deployment. And we're able to put it into blob storage and take it out of blob storage and be able to do this with client-side rendering that allows us to have very fast performance because we're bringing all the data into the browser. And since the data is stored in blob storage and rendered on the client side, we have very low activity on our app servers. It's very performant and it's very scalable, and it allows us to scale out that application tier tremendously to be able to handle lots and lots of data. But the data is very bursty. It's as soon as it flows through our system, basically the data load goes down tremendously. So what did we learn from working with Azure? So we were working with Azure from very early on, and one of the things that we found is that day one I was using IaaS v2, and I found that it wasn't available in certain regions, it wasn't available when I needed it, and so as you're adopting new technologies and bringing them into production, they're great to stay abreast of and to start using so you can respond to it when it's available for real production use, but you've got to be careful about being too early to adopt it and actually put it into production. Some other things, when you're testing this stuff, you've got to really make sure you do some resiliency testing, right? So we're using blob storage and we're very dependent on it, but these are just physical systems, right? And so what we found was one time Azure Blob Storage was giving us a lot of really weird errors back, right? It was saying that the network was busy, the network was unavailable, and after we worked with Microsoft support, what we found is that there was a router that had gone down. And because that router was down and it was connected to our environment, it actually was causing blob storage not to work correctly. So that's taking to sort of this next point is plan for errors. Actually make sure you code against those. These are PaaS systems, but those PaaS systems can still break. They can still have problems. And you've got to code, retry, put in logic where you can to make sure that you're responding to those types of events when they occur. And then the last thing is, when you're designing for a system, and when we were designing for our deployment, our industry is very, very cost sensitive. And so when we architected this and we continue to look at the architecture, every time we did something or made a decision, we wanted to ensure that we had cost at the front and center and that we understood what it was going to cost to run it at scale. And so those are kind of the lessons that we took away from this in our overall usage of Azure. Thanks very much.
So, thank you. So in terms of the next speaker, what we'd like to talk about is genomics and where Azure is being used there. So I'd like to welcome up Brad Sitko from DNA Nexus to talk about what they're doing with Azure. Thank you, Brad.
All right. First of all, for this room, how many of us have been in that situation where you want to do a live demo and something goes wrong? So who wants to give major kudos to Grant for going through that one? Because we've all been there. And secondly, just want to ask a question and to start the session off. So I'm going to talk. We're DNA Nexus. We do large-scale genomics in the cloud. And first, when I ask and do some level setting, who in the room is familiar with genomics? I know Mary is with the son at Illumina. So, all right, so not too many. Let me ask another simple question. How many of us in this room have DNA? All right, at least we're all on the same page now. So the good part about that is, from a business perspective, DNA Nexus, we love you because that means you're going to generate about 100 to 200 gigabytes of data for your DNA. So you can quickly see how if you take this room and this conference and all of Orlando and all of the US and all of the world, how this becomes a big data problem really quickly. So what I'm going to take you from is kind of the building blocks of life, which is your DNA, to kind of the building blocks of the cloud and our journey with Azure. But before we do that, first I want to set some context for you about genomics and why we think this is important. So with genomics, we're at the intersection of technology and timing colliding. We have these two beautiful megatrends happening. Illumina, as an instrument manufacturer, has created a sequencing technology that's outstripping the pace of Moore's Law in terms of data generation. Moore's Law has always been our benchmarks for things that are going really, really fast. So this has been deemed Flatley's Law, after the CEO, Jay Flatley of Illumina. The second piece is they're creating instruments that are driving data production at a rate that's far faster than anything we've seen before, and instruments that are more affordable, that have taken what was a $100 million genome to do during the Human Genome Sequencing Project in 2001 to now a $100 genome that's visible by the time we get to 2020 or 2021. So what is that going to do? That's going to produce 30+ million genomes that have been sequenced. Today there's been about 1 million max. It's going to require 700+ petabytes of storage, so we can quickly see why you need the cloud for that. And a small number of 1.3 billion core hours are needed. And that's just to get the basic data, like to get to the end point. That's not even starting to do some real analysis on it and understand what the data is actually telling us. Let's put this in context. Genomic data, bigger than big. Published study that looked at the sources of big data today. So look at Twitter. That's really popular with our president today. About Twitter, 1 to 17 petabytes of data a year by 2025. All of astronomy, so as we're looking at the beautiful stars above, about 1,000 petabytes a year. YouTube, 1 to 2,000. Genomics, when you have 100 million to 2 billion genomes sequenced, up to exabytes per year. And you think of that in comparison to YouTube, that's 2 to 20 times the amount of data that's on YouTube, and that is one heck of a lot of cat videos. So to put it in context, who's using genomic data? Genomic data is used pretty much all across healthcare and research and ag. So pharma and biotech companies are using it for drug discovery to help find targets that are going to help things like, cancer is the most obvious one, but autoimmune disorders. Diagnostic test providers for obviously diagnosing cancers, non-invasive prenatal testing is a big adoption. Universities are still doing groundbreaking research. Contract research organizations, ag bio plants like folks like Monsanto are sequencing crops to understand how to get better yield. There's been projects like the International Rice Research Institute that is looking at sequencing strains of rice so that you can figure out where to plant the best strain across the world, whether it's a dry or arid or cool or warm environment, and then our sequencing centers, and then a lot of government-funded projects. So genomics is all around us. DNA Nexus, let me give a quick overview. We're the leading cloud-based platform transforming genomics and precision medicine. We have worked with 100+ global enterprises, some of the logos which you'll see on the right of the slide, 10,000+ users, so we've really connected a community in the cloud. We're running at 10 petabytes on the platform today. I've probably processed almost 20 over our lifetime, but some people are still pulling data out of the cloud, which we'd all love to change, especially with Microsoft. We offer a platform that offers the security that Vamshi was talking about, the scalability of the cloud, and then the configurability for genomic data. We created this genomic network to bring researchers together because genomics is a very academically oriented environment and are focused on the commercial piece. What does our platform offer? I'll take you through this in a use case with our friends at Stanford University in a minute, but it gives you enterprise scale needs and access to the cloud to deal with genomic data and all the use cases around it. What did we need? We needed elastic compute that was on demand. So we scale from 1 to thousands of VMs routinely, millions of tasks running. We needed something that was efficient, that when we turned it on, it was on. When we turned it off, it was off. We paid for when it was on, and when it's off, we turned it off. And to give us and our customers that kind of flexibility. And we needed performant response because people are in an instant gratification world, especially with research. And so we needed something that scales as fast as we do when we're spinning up thousands of VMs. Our workflow is, if you think about taking the sample, which is like a cheek swab or a blood sample, gets put into the sequencer where it's basically bussed into many thousands of pieces and then sequenced, and then those reads are taken and put together. Think of it like running something through a cross-cut paper shredder and then assembling it back together, and make sure you're assembling it with absolute perfection. So it's uploaded, written into the block blobs, combined with VMs and then put back into the block blobs. We have Azure Resource Manager templates, and then we have VMs at scale to do the variant calling to tell you what is slightly different about this genome that you should know, because that might have the cause of why a patient is exhibiting a certain characteristic. And then have the ability to share and integrate with other types of cloud resources through our Conformant API and access it, whether you're an individual user, an enterprise, or a whole community of researchers globally. And that takes you from sample to answer. What I'd like to do, look here is just a day in the life of large-scale genomics. So this is a snapshot of one of our days. Start with 2,000 VMs, take a ramp down, and around midnight we're up to 3,000, spiked around 5,000. So this is what we need for scale. And you can see all of these colors on this graph are different types of VMs. We tend to use the D, F, and G family within Azure. But you can see why we need the availability of the cloud for that. So it's really significant. We love the dependability of Azure for this. And to take you through a specific case, that was a really nice piece and an example. We're working together with the Stanford Center for Genomics and Personalized Medicine, one of the leading research institutions globally supporting their genomics core. They're connecting 80 different labs on campus, 8 partner institutions across California and the US, driving a petabyte of data. They need things that happen instantaneously, so when it's coming off of the sequencer, it's going right into the cloud and being processed and delivered to their community. And this is supporting not only their internal research work on campus, but large government-funded research grants such as the ENCODE Consortium, which is driving the field forward. So this has been a big win for both DNA Nexus and Microsoft together. And we're thrilled to support that and happy to take any questions, certainly after the session. So appreciate Vamshi, you including DNA Nexus as part of this. Thank you.
Great, thank you, Brad. And so let's switch gears, talk a little bit about financial services and insurance, moving on from healthcare. So a lot of these problems around data, computation also reoccur in the financial services and insurance business. Slightly different flavor though, so it's worth talking about the scenarios where we're seeing cloud adoption. One of the most common areas in financial services that we're starting to see cloud adoption is compliance archiving. Right? There's a tremendous amount of data that gets generated in the financial markets in terms of what's happening with trading records, what's happening with consumer records. You call your, nobody calls their broker really anymore, but if you ever call customer service, the financial service industry is actually required to record those calls and keep those calls for compliance purposes. But there's really a lot of work that's being done around saying, moving from these very expensive on-premises systems to cloud-based systems. Here's a few of the partners that we're working with in this space. Another space that's really kind of adopted the cloud wholeheartedly is insurance, and this notion of risk modeling, catastrophe modeling, financial risk modeling across a variety of insurance industries is something that, again, it's a bursty computation workload. We have a customer here that will talk through that as well. So benefits of the cloud in this area, also the global data centers, because data residency is a big issue here in this industry. Security and compliance, as you would expect. Low-cost storage, long retention. We're talking, anywhere from 7 to 10 years as a minimum retention period to a lot of companies saying we want to keep this data forever. And then high-performance computing at a lower cost, as well as sort of these burstable cost models where you can run workloads, you can spin VMs up very rapidly and spin them down when you're done. One of the features that we're adding into Azure Storage, specifically for this industry, is warm storage, or immutable storage. Along with the requirement to store this data comes the requirement to prove to various regulatory bodies in Europe, in the US, and in Asia that the data hasn't been tampered with. So we're building this feature that allows you to essentially store data, mark a retention policy on it, and prove that the platform will not allow you to either delete that data or overwrite that data for the number of years you set. It will work across all tiers of storage, hot, cool, and archive. So whether it's active data that's being read or long-term archive, it'll work on all of those layers. And we're doing a lot of work with these regulatory bodies to come out with those compliance guidelines having been met, such that as an industry, adoption can take place without having to go through that on a case-by-case basis. So with that, let me ask TB, who's the CTO of Archive360, to come up and talk about what their company is doing with Azure in terms of building an intelligent archive.
Hello, my name is TB Pop. I'm actually the CTO and co-founder of Archive360. And I'm here today to show you guys, discuss Archive to Azure, which is our compliance-based archiving system based solely on Azure. But however, before I go into the demo, what I want to do is give you kind of the 3 pillars of our architecture, what it means to have a new modern intelligent archive. One of the things that we're focusing on today is companies are requiring is to store as much data as possible in a compliance environment and store it in its native format. So what we've done is using blob storage and so on. We are taking as much data as possible and wrapping it into a, so to speak, regulatory way to meet financial regulations and other laws. Number 2 is once that data comes into the system, what we're looking to do is make it available for search. The amount of data that comes into the system nowadays is so large, companies are not looking any longer to just search user desktop documents, emails, and things like that. They are also looking into searching video and audio. Hence why our integration with Azure Cognitive Services and Media Services to make video and unstructured content available for discovery. And given the amount of data that becomes available today, what is important is to shrink the data, the volume of data that people search and review. Consequently, we're using basically Azure machine learning to shrink down hundreds of thousands of files that are retrieved in a search to a more manageable size so people can read and review much lesser amount of data. Once all this richness of data becomes available, one thing that we need to do is we need to secure it. We secure the data in transit, we secure the data on disk, but more importantly, we integrate within existing Active Directory environments and other authentication systems of customers to basically provide a seamless way of access control all the way down to file level. This entire platform is pretty much built solely on Azure services. It has absolutely no VMs. It takes advantage of Azure Blob Storage, hot, cool, archival, even having warm functionality, but extends it into Azure Search for maximum indexing with cognitive services and so on to basically index structured, semi-structured, and unstructured data. So what are the key benefits for a large organization today? They can actually have one global compliance archive, which allows them to store any kind of data in an open native format. So we're not changing the format of those files once they're stored in their subscription. And 2, the whole application is actually integrated within the Microsoft Cloud, so Office 365 and SharePoint are fully integrated. So let me flip over to a demo and show you guys real quick a couple of items. Right. So here we have Archive to Azure, and we're starting up with a dashboard. The entire application is actually web-based. And right up on top here, we have actually our main components. We ingest data, and we have all the data cabinets and so on, the flexibility of indexing data on demand and as much as we need to. We have disposition and a bunch of other tabs. But most importantly, let's go through a regular use case where we want to search data. That's what everybody is interested in searching and discovery. So what I'm going to do is select all of our corporate data that we archived into the system. As you notice, what do we have? We have a lot of index fields, metadata fields that are available to us to search. Customers can optimize this based on their own requirements and extend the universe of metadata. And then let's just do a quick search and see how many files we have in the system. So pretty much right now, we just returned in within half a second 123,000 records. And this is really the power of Azure Search. It scales out dramatically. And we can see that we have all kinds of record types. So let's go ahead and do a little bit more interesting search and search for Azure and see what we get. So once we do this search, we return around 37 results, and we have a bunch of different data types. One of them is, we see in here, we have some emails. Everybody that works in the regulated industries, they know that they need to capture emails. So obviously, we store them. But one of the interesting things we have done is once you click preview, if you're a large organization, you might have emails in different languages. It comes in a specific language, in this case Japanese. Rather than printing it and having it translated offsite, by using cognitive services, we can actually translate the email right in real time. So Azure Cognitive Services supports roughly 53 different languages, so we can translate back and forth. This is in case of email. Moving forward a little bit is, besides email, we have Word documents and desktop documents and so on, so basically end-user docs. Those, rather than downloading straight to desktop, which is available, we're integrated with Office 365 Online, so all documents can be previewed right within the web browser. So users don't have to have actually a specific application installed to view their desktop documents. But we're going further even more. What we found in here is a video. And if I click on the video, what is interesting about it is that on the right-hand side, I have actually the video starting to play. But on the left-hand side, I have a transcript of the video. As we ingest video into the system, we automatically transcribe it and make it available for search. We also highlight the words that we have searched on, and we can actually skip to the video and go to a specific location and listen to that, hence shrinking pretty dramatically the amount of somebody having to review a video. Let's close this video and go into another interesting use case, is voicemails. And right in here, I have a voicemail with a specific user. I open it, and the voicemail starts to play, and I have the transcript of the voicemail. The same thing as a video, but no image. What is great about this is if companies are doing surveillance and trying to do discovery on VMs and so on, right now, as the data comes in and is being placed into Azure, we actually index the content of it and make it available for export, including the video itself or the voicemail itself, plus the metadata associated with it, the transcript. Taking it even a little bit further is Azure OCR, Media Services OCR. And right in here, we have actually a contract, a EULA. If I open this EULA, you can see that it's actually a scanned document. What's great about it is, so until today, you will put the document in there and you could not search it. As we index the document, as we ingest the document, we actually OCR it in real time and make it available for search. So what this whole system does, all in one shot right now, you're not anymore putting in your archive and making available for search just regular ASCII documents, user desktop documents. You actually have video, audio, and images that become available for end users to use as well as business units. And with end users in mind, we also want an integration point. And you don't want end users to come in into a different application. Hence why we also have a native SharePoint Online application that allows end users to log in with their own credentials and basically search the data that they are allowed to see and retrieve it right of archive to Azure using native SharePoint. So that's pretty much in a nutshell what Archive to Azure does from a high-level perspective. So let's go back to our presentation real quick and highlight a couple of highlight a couple of case studies that customers have done. In this case, this is a financial services company which over $140 billion in assets, and they decided to move to Office 365. And part of that move, they wanted to also streamline and optimize the cost of their journal archive. So they ended up taking everything that was within a legacy archiving system and forklifting it and moving it into Archive to Azure, driving drastically down the cost of their compliance storage system and so on. This is a very standard use case for FinServe. Let's cover a little bit another customer of ours, Target Insurance. They are a large insurance provider in the United Kingdom, and what they're currently doing is forklifting their on-prem data centers into Azure. Part of that are file servers. A lot of that file server data they want to take into into SharePoint Online, and basically part of it the stale data, take it into Archive to Azure. We're able to forklift the entire environment into Azure, and basically with the native SharePoint app, end users are still able to access their legacy data if they need to. So to summarize things is, what do we have? We have an archive system that is able to retain any sort of data type, video, audio, regular text documents, turn it into information. With analytics, go in, scanning video, audio, search, and so on, putting regulatory compliance about it, and basically deploy it to a bunch of industries, such as, financial, healthcare, and insurance. If you guys have any other questions after the demo, I will be around. Thank you.
Thank you, TB. And now I'd like to ask Christian, who works with Aegon in the Netherlands, to come up and talk about how they are using Azure to do high-performance financial modeling. Thanks, Christian.
Good afternoon. I'm in the second scenario in the financial services, risk modeling. As you see, I'm coming from the Netherlands, Aegon. Probably better known in the US here as Transamerica. And let me see what, the other way around. Some numbers about Aegon. We have 30,000 employees. We are busy in life insurance business, pension business, and in the Netherlands also in non-life. And my role in Aegon is in finance department, work with the team to make the models right for the other professionals to do risk management. Yeah? So I'm not really an expert in financial risk management myself. I'm more an expert in how do I structure models, how do I organize it. And this is some kind of small summary for you about work we did together with Microsoft and a lot of my colleagues. So what's we about? We are doing cash flow projections. Market risk, shock analysis, complex scenarios. What happens if the market's going down? What's market's going up? But also all kind of different things we have to do for regulations. And specific scenarios in our area are Solvency II, IFRS 9. That is also here in the US. IFRS 17 is coming up. It requires us to make a lot of calculations, make cash flow projections for the next 60 years, to run different scenarios, and that's quite a lot of work. But I'm also in the business with a lot of finance people that push the button and just wait for the result. So I have a workforce that just is waiting till the result is there. So speed is very important for me. And the other side, I have a lot of people looking to my models, so I have to look to transparency. So we started off with, I have another there, with blob storage. We started up with a new model for modeling. We used quite a lot of actuarial software suppliers, which limits me in licensing, and I need to hire specific consultants. So we like to go for a more open source situation. So we build models now in R. And it starts all with the blob storage, where we have our code, we have the application R, we have the input data we like to have, and then we spin off an Azure batch, the HPC as a service. In this example, 4,000 VMs. This is for this model, just to give you a feeling for how big the numbers are. but I have 40 models of this size, all with different setups. The cloud enables me to choose every time different setups. Where I had in the past we had an on-premise situation where we were locked with 200 VMs. Then we start loading the application in. It installs R. It installs the package. It starts doing the calculation runs. We bring also the input data there. But then I come with 4,000 VMs with all kinds of small pieces of calculations back to the blob storage, and I create some kind of traffic jam for myself. So I want to push as quick as possible 2.5 terabyte in, and we were not so successful with that. And the idea is then from the blob storage to bring it to data warehouse, SQL data warehouse. So I had to find something to make sure that the overload is solved, and we had a large runtime. So this whole thing was running and around 27 hours, and it was a bit too much. All these people are waiting, quite expensive actuarial people, financial professionals. So we want to do something different. I understand now the current situation looks almost the same, but we started with creating more child accounts. So we scripted it out in multiple accounts. So we can have multiple accounts and multiple VMs, and then randomly let them select the account where they take the data from. And then the same story starts. You do the Azure batch, to see there, 4,000 VMs, but now they can subtract randomly from these different accounts the data, and it gets a lot of more speed. Specifically when we come back in, where we had in the first scenario a runtime of 27 hours, this is now running in an hour, which is quite acceptable for me. Of course, I was here in Orlando looking around for new options to even speed that up, but now we have a nice performance. And then we go to Bolybase. The whole thing for this model, this is our mortgage calculations for the Dutch market, is running in total 4 hours. And that is quite acceptable because we're coming from a situation that we run this differently on a SQL server, and all the runs together took us 3 days. So people were asking now on Monday morning, these are my numbers, do I have them on Thursday? Yes, you have them on Thursday. If they give it now on Monday morning, I say by lunch I have them for you. And that's a large difference for us because we can make much more quicker decisions, and more speed up the work. Conclusion, we are really happy that we can have more parallel computing in the cloud. I don't think I could go to my boss and say, I like to have 4,000 VMs on premise, specifically for this model, and I like 6,000 for the others. So that will not work. I'll skip through the other things. We have less independency on the underlying model. But I think the big learning we did is handling so much data, you still have to structure it a bit and think about your technology choices. So there was a lot of interactions with the Microsoft teams to solve this. We have even still contact to go also for the next steps now. And that's also what I like on working in the cloud. It's not about that new technology is there, but it's also a lot about knowledge sharing and use all the knowledge in the market to get an optimized result. The future, we still have hoped, and we worked already quite hard on that we can skip this child accounts or be more in automating deployment from that. Now it's hard-coded scripting for 24 accounts. It's not too much, it's not too difficult, but it would be helpful if we can skip that. And work on the SQL data warehouse autoscaling. Yeah, that are quite summaries for now. Thank you for your time. Any questions?
Thank you. So you can see how all of these customer stories are going across the board in terms of data storage and computation over that data. So we have one more industry in terms of the after financial services we want to cover is architecture, engineering, and construction, or frequently abbreviated as AEC. So in the AEC space, this is a little bit different because one thing that happens is a need for a lot of collaboration and sharing, where lots of engineering construction firms, there are projects that are happening in cities around the world, in cities around the US, and there's a lot of data. The engineering firms are so data-driven now with the software models, the files, etc., and sharing that data. So you have many professionals, engineers, designers, architects, etc., collaborating on these very large files. You also then have an archiving and retention problem. You need to retain, understand what you're retaining, and understand what you can dispose of in terms of these large volumes of unused data. We have a number of partners in this space. Nasuni and Penzura build global file systems with a way to really collaborate across many, many branch offices. SoftNAS builds a great NAS in the cloud for the ability to use this. And a partner, HubStored, also does some great work around archiving. So here, cloud storage benefits are around the global file system, the ability to keep a master copy in the cloud and make all your copies on your branch offices caches effectively. So the sync problem is handled in a very, very different way. You also have high throughput storage, so when you have these large files, downloading them quickly, uploading them quickly makes it easy. And again, the scale and the low-cost storage matters, of course, here as well. One of the big features we launched at Ignite around this space is an archive storage tier and blob-level tiering in response to this industry's needs and many others, is the ability to have offline storage. So if you are storing data for a long time, you don't need it immediately, we now have an archive tier for you to store that data for years or decades and have a few hours of latency when you do need it back. But we also have this hot and cool tier, which is around giving you instantaneous access to your data at different cost points. We now, with blob-level tiering, allow you to mix hot, cool, and cold data in the same storage account, so you can, as a storage administrator, make the right choices with the solution you pick on how much data is hot and actively used in your enterprise, how much data is, maybe used, but you can pay less money for that, and how much data is just being held for retention and compliance reasons. So with that, I'd like to ask Andy from WSP to come up and talk a little bit about how they're tackling this problem. I'll also like to welcome Jeff, who's the CEO of HubStore. Thank you, Andy.
Connected there. So yeah, I'm Andy Saunders-Lyceum from WSP. I'm actually based in New Jersey, but we're spread out across the whole of the US and the rest of the world. We are a global engineering company, professional services firm, 7,000 engineers across about 100 offices across the US. And we design, build bridges, tunnels, buildings, power stations, you name it, we build it. And our infrastructure is pretty much what you would expect a typical engineering company to be. It's one connected offices through an MPLS network. We have two main data centers, one on the East Coast, one on the West Coast, where we store corporate systems and corporate data, email systems, that kind of stuff. And in the offices, what we have is, file servers, which are your typical Windows file shares. They're either running on NetApps or through Windows file servers, or through VMware. I won't mention that here, though. And across all of those offices, we've got around a petabyte of data, roughly. And it's all unstructured. It's just file shares. It's just various types of files and documents. And that's exactly what this shows. The office files, spreadsheets, financial spreadsheets, Word documents, CAD drawings, which are either small CAD drawings that have lots of embeds or very large XREF documents, etc. 3D modeling, and even into our animations and 4D. We have a part of our business that will do 4D rendering of a project as it gets built out the ground as a 3D demo. So the problem we've had is it's simply, the guys out there doing the work, building the bridges, designing the roads, etc., they just keep creating files, they just keep creating data, and it won't stop growing. It never has. I've been with the company now for 19 years, and I see 19 years worth of data on our servers when I look at it. It's just out there. That gives us a number of problems. It complicates our backups. Just completing a backup within a window is incredibly difficult. And achieving retention policies that the business wants without huge, massive backup devices is also difficult, you know, and we have to expend a lot of money on those things. And then migrations, you know, just moving, we have like a 5-year refresh cycle where we take file servers and we'll dispose of them after 5 years. We have to migrate the data to something else. Just doing those migrations take time. We're 3 weeks into migrating the San Francisco EMC to a NetApp, just copying the data to get it across and get it in sync. And when I look at all these cool, files on demand and OneDrive and SharePoint and all these cool things we've heard about this week, I think, okay, but we need to transfer a petabyte of data into the cloud before we can go there, and it's not going to work, you know. And disaster recovery, well, that's easy. We don't have disasters, so we don't have to worry about that. We just stay away from disasters and we'll be good. The biggest issue for me from a management perspective is, 70% of all the data that's on those file servers probably hasn't been touched, no probable about it, hasn't been touched in the last 3 years. So that's 700 terabytes roughly of data that hasn't been touched in the last 3 years. And we're still moving the data, still securing the data, still reackling the data if we need to. We're still looking after it. And the users are really just creating, using, and then abandoning the files, and then it becomes our problem. So we needed to find a way to control that data and the data growth. And so we found a solution in HubStore. Obviously, everybody's going Azure now. Everybody wants it in the cloud. Nobody wants anything on premises. And really, our business is also driving for, we don't want CapEx. We want OpEx. We want to reduce ourselves down to, everything is not on-prem if we can. We look for anything that's Azure-based for whatever problem we may have. So, HubStore is an on-prem solution. An Azure-based solution. And it's actually deployed into our Azure subscription. So you can take out a subscription through HubStore, or we just used our own tenancy, our own subscription, and actually HubStore themselves populate and build the system. We don't have to actually install the software for the core system. And it works through three phases, I guess, is a right description. Each one has its own policy, so the policies around the last access date, the file types, the various criteria that hits on a file. And so the first policy says, when I run, I want to copy the file up into Azure. So I'm just going to take it from the file server, I'm going to take a copy, I'm going to put it out in Azure. And that's where it stays. On its next run, the system actually looks again and says, okay, well, that file has gone up to Azure. Let me stub it. So now it removes it from the server and puts it, you now just have it in the cloud, but you have a seamless stub. So the user goes back to where the file was, double clicks it, and it's there. So the users don't really know we've done this, which is good. And then the final stage is, I class it as optional, which is migrate, which is to say, at some point you might just want to remove the stub. And if the users need access to the data again, you're just going to go out to the end user portal and search for it. I'm not sure we'll use that, but it's there. Finally, I guess the big piece for us is that all of the permissions stay. So it's synced to Azure AD. All the ACLs stay the same. It's flexible recovery, so we can rehydrate the data. We can, if we lose all the stubs, for example, we can actually run a script that will put the stubs back for us. Zero lock-in from HubStore is actually a really good thing, and this also helps justify the cost of the thing. HubStore don't require you to sign a 12-month or a 3-year contract. You sign up, you go in, you start to ingest, and for whatever reason, you can just stop your service. But it's in our tenancy, so the data stays with us. We just don't obviously have the extra bits. And then the data insight allows us to see from the portal the age of the data, the types of the data, the kind of information that we've sent up there. So that's really what WSP are doing to try and combat our storage problems. And I'll hand over to Jeff, who's actually from HubStore, to tell you a bit more about the product.
Great, thanks for that, Andy. So who here has had it said to them that there are three things certain in life: death, taxes, and continued data growth? Okay, so it's a real problem, as Andy's highlighted. We see this happening all over the place. Okay, and the one thing that is consistent is that all of the data is active at some point, but not always, right? And it's going to fade. It's going to quickly go into this period of, or this state of being inactive, low touch. And so that's a great candidate for the cloud. And with HubStore, what we're doing is helping customers like WSP go into the cloud without changing the way they work. So they can take their NetApp SIFs shares, or they can take their Windows investments, their Windows Server investments, and without disrupting users or applications, they can go in with policies and simply start to bring this data into the cloud in a seamless way. Now, this obviously helps to shrink backups on-prem. It makes them very agile. And as Andy kind of illustrated, that we have the ability to pull data out of the cloud at any point, but also leverage this storage tiering concept so that we can assist with hardware refreshes, storage migrations, ransomware recovery. We essentially remove the data gravity problem on-prem. Now, in the cloud, instead of just treating this as dumb storage, we want to be smart about it, okay? So one of the ways that we do that is we wrap block blob storage with analytics, search, and a near real-time policy engine. So the policy engine handles a number of sophisticated data governance scenarios, think things like legal hold and whatnot, but it also helps us do storage cost analysis. So at WSP, we plan to use the chargeback feature to be able to tag data in the archive and attribute that storage consumption in Azure to different cost centers in the business. Now, that's sort of a future item, but it's there in the product today, and most of our customers will start using that over time after they've seeded a lot of the data. But also, we integrate with the new archive tier, and this is where policies and analytics really play nicely, because we can show you where you have data sets that make sense to go down from hot to cool or archive. Obviously, you don't want to put active data into the archive tier because you get stung with the activity costs. With the analytics and insights, we can be very selective and target data by access rights folders, last access, things like that. So thank you very much.
Thank you, Jeff. Thank you, Andy. So I hope you've seen through all of these customer stories that this is not something, when we talk about storage and Azure being used in key industries, these are all real scenarios. These are customers across a variety of industries really using it. So to wrap up, I want to spend a few minutes just talking about our last vertical, media and entertainment. I would have loved to have more customers up here, but I only have 75 minutes, so I can only fit so many customers in a session. And I already caught a lot of flack from our marketing folks for trying to fit 5 customers in. I'm glad that went well. But when we talk about media and entertainment, Azure has been at the forefront of media and entertainment for a long time. Both in terms of the first-party services we build with Azure Media Services, but also with the wide variety of industry partners that we've had. This is just one of the verticals with broadcasting and online video and this huge universe of partners that we interoperate with. What does this mean in the storage world? Where do we see adoption? There's one area where we really see it, which is this notion of going from raw footage to post-production to play out and then archiving. So that's sort of the media workflow for a lot of systems that push data from the point you shoot something, or shoot an episode of a show or something, you do all the visual effects, the rendering, then you do the transcode, you do delivery to VOD systems or to cable channels, and then you archive that data. We have a number of different partners in this area. I'll highlight a couple. The other place is, even if that part of their system and the workflow is not online, media storage and archiving is moving in a big way to the cloud in terms of being able to tier what's on-prem, because it's a lot of, again, inactive data, and also being able to put things like full versions, like mezzanine files. You talk about 4K footage and 8K footage, it's hundreds of gigabytes for an hour's worth of 4K or 8K footage. So that data is also naturally moving to the cloud rather than growing on premises. Again, we have a number of partners here, both media-specific as well as the normal players you'd expect in the storage space working with us on cloud partnerships. Cloud benefits here, again, ease of use and scale, low-cost storage sharing. But there's some interesting stuff we can do around metadata enrichment through media analytics, streaming scenarios, VOD. Like we barely, more and more people hardly ever consume TV by turning on the TV, right? It's on our phones, on our tablets, and all of that is delivered off of content delivery networks with cloud storage like Azure Storage at the back end for origin for that long-tail content. So one of the features we've added in this area around Azure Storage, security is a huge thing, especially when you're in that post-production phase and you don't want footage leaking on the internet. I mean, there's been all these high-profile leaks of data that, think HBO and Game of Thrones episodes leaking on the internet. You kind of have this problem in this industry and also many other industries. So we're adding this notion of firewalls and virtual networks where you can take your Azure Storage account, which has a public endpoint, and then turn off that public endpoint. You can only have access from your corporate internet address ranges or a virtual network inside Azure. So this is a feature that's in public preview and moving to GA soon. Thanks. So one of the things that we do want to talk about here is our partnership with Avid. Avid is the industry leader in post-production for a lot of, if you're watching a show, sorry about the switch over there, we announced at NAB this partnership with Scott Guthrie and the Avid CEO to really build a strategic partnership with them. At IBC last week, we announced a lot of work with them, the first steps of that partnership, including their Media Central asset management systems now being able to tier transparently to Azure Blob Storage. So we're going to do a lot of work with Avid as time goes by in terms of building a very comprehensive post-production platform all the way from shoot to archive on the cloud. So even though this has been a long time, I wanted to ask a question in terms of how you have seen this stuff come up in terms of Azure usage. How many of you watched the Olympics last year? It's over a year ago now. How many of you watched it on a tablet or a phone or something, rather than the TV? So a lot of this, especially in the US and the broadcasters around the country, was actually running on Azure. So there were 8 different broadcasters globally that were doing their entire Olympics coverage off of Azure. And particularly in the US with NBC. So the numbers here were pretty staggering. We're talking about billions of minutes of streaming. We're talking about petabytes of data coming off of the origin, and really a pretty amazing experience for consumers. I don't know if you remember, 8 or even 12 years ago, you'd get this highly curated set of sports that you could watch on NBC, and that was about it. If you liked some sport and it was an odd time or whatever, you were out of luck. Here we had 500 live channels streaming off Azure, so you could watch your favorite sport, and all of that was immediately turned into video on demand. So if you didn't catch it at the time of its broadcast, you could go back and catch it. And that was nicely packaged into this NBC app in the US, where you could have it on your iPad, on your phone, on your tablet, and really just be able to watch what you wanted when you wanted to watch it, everything powered by Azure in the background. Another cool example of sort of video changing the industry and video sort of really helping, I love this case study. It's a partner of ours called Live Arena, whose mission is basically a television channel for anybody at any time at very, very low cost. They've partnered with this hospital to build what they call, this is the second or third year that they've done it, called Worldwide Robotic Surgery Education. If you're familiar with the surgery space, it's incredibly expensive to get doctors to take time off, go to a conference, learn new innovative surgery techniques, and also operation theaters aren't really conducive to a whole bunch of people crowding into an operation theater while there's a patient there. Now, there's always been closed circuit systems, recordings, blah, 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 but the interactive, the live nature of this, the ability to ask questions, the ability to learn collaboratively is a key space here. And Live Arena partnered with Karolinska Hospital to build this and really do an amazing job of people, doctors from around the world being able to drop into this live conference, ask questions. So it's a pretty cool case study. I really enjoyed this when I looked at what they had done. Another thing that we always talk about with media and the media industry is how do you get the data in? You know, again, with shooting footage, footage happens at various remote locations, right? No network connectivity. So one of the things we introduced at Ignite is the Azure Data Box and the ability to get 100 terabytes of data at a time offline into Azure from anywhere within a week or so. We are able to build these things, get them out to customers. We've been in preview for a long time. And we're also partnering with a number of partners because just dumping the data on there isn't the right thing to do. We have to be able to bring the data in the format that you can use. An example of this in the media space, and it's actually kind of the IoT space, is this company called Oceaneering. So let me roll this 2-minute video.
This is our 51st year for Oceaneering, and we started off as a diving company. We had requirements from customers to go deeper, so we moved more to a robotics type of company, and the ROVs is where that business really grew. For Oceaneering, the data is becoming more critical. We have people distributed all around the world, and they don't always have connectivity. Historically, a pipeline inspection would take 6 to 7 months from the time it was inspected to the time the engineers are actually looking at it. An ROV itself will generate 2 terabytes a day for inspection data. The vessel can generate up to 10 terabytes a day.
What the data box has done for us is given us a platform that we can ship, plug in, extract data, and get to the Azure cloud pretty easily.
We're trying to move all the data delivery from the field to within a 7-day time period from anywhere in the world. We're trying to get the data to the decision maker quicker. The Azure Data Box does reduce the overall time and speed for delivery for a client. The cloud scenario has been a game changer for us. What that allows us to do is consolidate it all up into the Azure cloud to a central repository, and that saves us time. Once the data is up, the cloud has enabled us to do all these technologies against it that we wouldn't have had the horsepower of the processor to be able to do locally. Within a week, usually the data is available on the web interface for the client to be able to view or to do analytics against. For a business, data collection is a requirement to really start enabling tools such as predictive analytics. We envision the data box scenarios that it is deployed in all the regions worldwide, and it allows us to broker and curate the data so that when we give it to a client, it's meaningful. They know what it means for uptime, what it means to protect the asset that's out there. That is what's going to drive the savings to the client.
That was a pretty fun project for us as we were in preview and working with Oceaneering. So just to wrap up and sort of summarize what we've seen today, even if you're not in one of these industries, the workloads, if you think about them, are basically we've covered cloud storage as a primary storage, we've covered archive storage, we've covered an IoT scenario, and we've covered a couple of HPC, big data, and analytics scenarios. So think about these areas, and there are many others, of course. We can only, again, fit so many customers into a session. But when you think about your scenarios and where they apply, think about whether there are things from here that you can apply back to your scenarios. So in terms of what's next, a lot of these talks are completed, but I put the codes up here. We will be here after the session for the next 30 minutes. If you want to talk with us or with any of the speakers, please do. Our booth is almost done, but if you want to meet with us tomorrow, just fill out this form. We'd be happy to meet with you one-on-one and look at things. And you can always email us anytime at Azure Storage Feedback. So thank you so much for being here. And I know it's the second last day. I hope you have fun at the party tonight. And please, if you wouldn't mind, fill out your evals. Thank you.